Assalamualaikum warahmatullahi wabarakatuh, and best regards to my viewers, especially to my panel, Mr. Adelan and Mr. Cik Wan. My name is Muhammad Nur Afif bin Hasni. So today I will present about my final year project with name Development of Dual Axis Solar Tracker using Arduino. My supervisor name is Encik Zai Hasraf bin Zakaria. So to start this presentation, I will start with the description about this project. So first, I will describe a little bit about this project. So this project is developed based on current invention of usage to solar energy. As we know, the popular mechanism that manipulates solar energy to an electrical energy is using the solar panel. The single axis and the static solar system is two concepts that popular in this invention, but the concept of dual axis solar tracker device has not fully exploited. Those two concepts, according to the research study that I have done, it has a low performance and not very effective. Therefore, this dual axis solar tracker that I evaluate and I develop to see the effectiveness on the performance, especially on the efficiency of the output voltage of the solar panel. So for the second point is the problem statement. Based on the description that I told earlier, we can pull out several problem statement to use to conduct this project, which is the number one is the solar array that use only in fixed installation. The second one is the solar panels doesn't aim towards the sun in continuous gesture of the earth, because the static and the static solar panel cannot follow the orientation of the sun towards the earth. So the lastly is the efficiency of the power generated from the solar. For the third point is the objective of this project. The objective of this project is based on the problem statement that we have stated. To solve the problem statement, we have the objective to do, which is the number one is the dual axis implementation for tracking system, which is what we want to do. So the number two is the development solar tracking system with supported by LDR, which is we use the LDR to sense the sunlight to get the orientation of the sunlight towards the earth. And we have, for this implementation, we use 4 LDR to get to sense the sunlight and to catch the sunlight to orient, to make the solar panel move towards the orientation of the sunlight. So for the third one is the alteration for more efficient tracking system. And the last one is to make best use of solar tracking system, which is to make best use of solar tracking system is of course to utilize the performance of the solar itself. For methodology, I have 5 main criteria that I have stated, which is the number one is the information gathering. For this point, I do some research about the development of dual axis solar tracker. Not only the dual axis, but also the single axis solar and the static solar panel. I do the research is to understand the criteria that important for develop the dual axis solar tracker, which is to get more information about how to build or to develop the solar tracker, and also to get the acknowledgement with the past technology that used to develop the solar tracker. So for the past technology, they use only a sensor, and some of them use not only a motor as a driver, but they use a hybrid to move the solar panel. So for the second criteria is the system design. In this part, is for me is hard part because which is I need to develop and design the circuit and also the coding for Arduino, because I use Arduino as a processor to move the solar panel. And rather than that is to determine the suitable and the correct component to be used for the technical and mechanical part of this project, which is for the technical, of course the solar panel itself. I use a polycrystalline solar panel. To compare the polycrystalline solar and monocrystalline solar, of course the poly has a low efficient and a low price because of course of the cost of this project. So but the most important is to see the effective of this solar tracker. So for the third is system development. After design the circuit and develop the coding, we have to assemble the component used to the circuit. This part is about soldering the component and to complete the circuit in the board. For the testing criteria is actually is to do the experimental part, which is to get the result for the criteria that I want to see, which is the power and the voltage output from the solar panel. To compare the output power and the voltage from the dual axis solar panel and the static panel. So the last one is for documentation. Documentation is about the to transfer the recorded result to the table accordingly, which is the table of power and static and the dual axis, and the voltage static and dual axis. And after that we make the comparison using the bar graph or the pie chart. For the result, I compare the result from dual axis solar tracker and the static solar panel that I have, as the result shows that the power generated from the dual axis solar tracker is higher than the static solar panel. So this proves that the dual axis solar can solve the second objective and problem statement, that is to keep the solar panel towards the sun orientation gesture, which is use the LDR as a sensor to catch the sun orientation. This is proof that the effectiveness of this dual axis solar tracker. From the graph, we can see that the result from dual axis solar tracker, in morning towards the evening, the output power and voltage doesn't decrease so much than the static panel. So this proves that the orientation of the solar panel is the factor to alter the effectiveness of and the performance of the solar tracker. So for the conclusion, dual axis solar tracker can utilize the power that can be generated from solar panel with the LDR sensor as the medium to catch the presence of the sunlight. With LDR and the orientation of the solar panel by stepper motor that I use, this system can constantly trace the sun during daytime. Lastly, from the result, we can see the improvement in efficiency of the dual axis solar tracker than static panel. So the conclusion is that the solar dual axis solar tracker is more efficient than static solar. So for the future work of this project is this development method can be implemented to country where a large part of electricity is generated from the solar energy. So they can use this dual axis solar method to their solar system. So and also to study the reliability device that can be observed, such as the material used in the solar panel, because the different material that used to in the solar panel can a little bit change the result. So other than that, the automation orientation solar panel due to change of time, which is we can set the orientation to the Arduino based on time, but we have to calculate the degree of the orientation gesture in the earth and towards the sun, and also the stiffness of solar PV panel from the change of weather. As we know, in earth we have many changes weather. We have summer, autumn, and many more. Mostly in Malaysia, we towards the end of the year we have a monsoon, right? So have a heavy rain, so maybe the heavy rain can affect the performance of the solar panel. So that can be future study of this project. So for the last one is the demonstration of this project while I do the experiment. Thank you. Sekarang LDR akan sense cahaya. So buat masa sekarang cahaya yang ada adalah lampu di atas. Jadi saya akan test fungsi LDR ke 44 LDR berfungsi atau tidak dengan menggunakan torchlight. Untuk bawah, kiri, kanan, hingga ke atas. Alhamdulillah fungsi semua berkeadaan yang baik.